So section 14.3, Trig identities, these are pretty easy to remember. These are the basic ones. Identity means that it's just always true. So there's classifications for these that might make it easier to remember. So these are called the reciprocal identities, and you've seen them all before, but let's list them. It's good for review. So the cosecant of an angle, theta, is just 1 over the sine of the angle. Those are equivalent. It's always true. The secant is the reciprocal of the cosine. So 1 over the cosine of the angle, and you have memorized that because supposedly it takes a second to go to cos co. And then the one that's the easiest to remember is cotangent. Theta is 1 over the, what does cotangent go with? Tangent. 1 over the tangent of the angle. Now, we use these identities to simplify expressions. For example, if I see cosecant in something I'm trying to simplify or solve, I'm going to change it to 1 over sine, because that's easier to simplify. So that's how you're going to use all these. There's the identities related to tangent are, and you've seen this before, the tangent of an angle is the same as the sine over cosine. We often make that substitution when you're trying to simplify a trig expression. You'll replace tangent with sine over cosine, often, and sometimes the other way. And then the cotangent, since the cotangent is 1 over the tangent from this, since the cotangent is the reciprocal of tangent, we would just take the reciprocal of this. So the cotangent is the cosine of the angle over the sine of the angle. It's just the reciprocal. And sometimes, so when you see cotangent in an expression, you would replace it with cosine over sine. Now, and the last set of identities is the Pythagorean identities. Of course, they come from the Pythagorean Theorem. And these are really commonly used. Here's the most common of all that's used, is sine squared theta plus cosine squared theta equals 1. And from that, in your homework, what I'm gonna have you do is, if you take this whole thing and you divide by, this is part of your homework, you're gonna divide every single term, because you have to, the distributive property, by cosine squared theta. You will get this, and it's also an identity. You will get 1 plus tangent squared theta equals secant squared theta. So, and the reason I want you to derive it in your homework is so that you don't have to memorize it. You would take this and divide everything by cosine squared, and you will get this when you simplify it. You can see where the 1 comes from right away. Sine squared over cosine squared. Actually, that is tangent squared. When you divide that, cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. Why? Because secant squared is 1 over cosine from up here. So, and then the last one, you will divide everything by sine squared. Divide all 3 of these by sine squared, and you'll get 1 plus cotangent squared theta equals cosecant squared theta. So these, the ones I'm going to box, are the ones that you use, but this one, as long as you memorize that, which just comes from Pythagorean Theorem, then you can derive the other 2. So let's do some examples like the ones you'll be doing in your homework. So the objective, or something on the test, would say, which is not next week but the week after. So it would say something like, find the values of the other 5 trig functions of theta. That's the direction for most of your homework, and the objective, the skill. And if we have a quick quiz, it'll be this. So first example is, let's say you're given that the cosine of the angle is 1/6 and that the angle theta is between 0 and pi over 2. And we want to find, so it says find the value of the other 5. We know what cosine of the angle is. The cosine is 1/6. There's 5 others though, right? There's sine, tangent, cosecant, cotangent, and secant. Okay, but we know this. So the first thing we're going to do is we're going to draw a picture. Always. So draw a picture means make an XY coordinate plane and draw a circle. It's not necessarily a unit circle. In fact, in this case it can't be because we're going to draw a picture, right? So for theta to be between 0 and pi over 2 radians, that means quadrant 1. So it's in this quadrant, so we'll draw a picture of our angle rotating through. Here's theta. Here's our triangle. Let me make that a little bit neater. Here's theta. Here's our right triangle. And the cosine is SOHCAHTOA. Cosine's adjacent over hypotenuse. So adjacent is there and hypotenuse is there. So notice the radius of the circle is 6, so it's definitely not a unit circle. And we're going to find all the other ones. So we would do review of Pythagorean Theorem to find the missing side. A squared plus b squared equals c squared. So 1 plus x squared equals 36. Subtract 1 from each side. And when you take the square root, you get plus or minus the square root of 35. Now, square root of 35 can be broken down to 7 times 5, but there's no perfect square in there. 7 is not a perfect square, 5 is not a perfect square. So we leave it, square root of 35. But do we choose positive or negative? This distance right here then, it represents going up, right, in the coordinate plane. So it's positive. So that's why a picture helps you get the signs right. Because in trig, if you don't get your signs right, you still are not getting it right. And if you can see where it is, it's positive, positive, right, to get to this point. That means you have to go to the right one and up root 35 to get to this point. So it's positive root 35. Now, using the picture, we can easily answer the question. So we already have cosine. Let's do sine. So sine of the angle, you tell me. SOHCAHTOA, sine is opposite over hypotenuse, so it's opposite is root 35. Hypotenuse is good. So sine is done. Tangent is, by definition, opposite over adjacent, so that's just root 35. We're not going to put over 1 because that's the same as not seeing it at all. So tangent's root 35. Always do the basic functions first, then do the reciprocal. So let's do the reciprocal right here. For sine, cosecant then is the reciprocal, right? So that's going to be 6 over root 36. But we're going to do this on a, we're going to,
Why is it square root 36?
oh, that was a mistake. So it's root, thank you, good. Root 35 over 6. Very good. And now we have the cosecant of theta equals 6 over root 35, right? But we need to rationalize, what do we multiply by to rationalize the denominator? Good. So it's 6 root 35 over 35. If you multiply the numerator and denominator by root 35. And that does not simplify because nothing divides evenly into 6 and 35. So we leave it like that. And then cotangent of theta, the reciprocal of root 35 is 1 over root 35, which is rationalized as root 35 over 35. So you leave it like that. And then cosine, we need the reciprocal of that, which is secant theta, which is nice and easy, right? Reciprocal of 1/6 is
6.
very good. Okay, so you would box all these answers so that I can find them. And that is, we're going to do one more example, which you should be able to do without me. So number 2, I'm going to move over here. I'm going to do number 2 here. So let's say you have the sine, you're given the sine of the angle is -3/7, and theta is between pi and 3 pi over 2. So draw a picture. That's so important in trig. Draw a picture. Picture means your little XY coordinate plane and a circle. So you rotate around to the point. That's theta. Theta is between pi and 3 pi over 2. You have to know that that's quadrant 3. 1, 2, 3, 4. Pi is here. 3 pi over 2 is there. So you always form, remember, always form your right triangle with the x-axis. So there's your right angle. And so we rotate around like that, right? But we only care about theta, this angle, when we say theta, the one that's formed that's to the x-axis. So opposite over hypotenuse, opposite goes here, hypotenuse goes there. And then we do a squared plus b squared equals c squared. So what you'll get is x squared equals 40, or x is plus or minus the square root of 40. So let's review simplifying that. What's the perfect square in 40? 4. So it's 2 root 10. So 4 times, so it would be plus or minus. Well, first of all, do we want plus or minus? That's the question. We only want to use minus. Yeah, because you can see in the picture that you're going to the left and down, so it's a negative, negative. So only negative, and this is the square root of 4 times the square root of 10. You can break it down. And this is a perfect square, so it's -2 root 10. And that's the best you can do for that. So now we can answer all of our questions. We already have sine. So what's the cosine of the angle? Adjacent over hypotenuse. Cosine is? Negative, good. -2 root 10 over hypotenuse. And does that simplify? Nope. So that's done. Tangent is we know it's opposite over adjacent. So that would be, remember you're picturing theta right here. Theta right there. So the opposite is -3 and the adjacent is good, -2 root 10. Now we can't leave it like that. What do we multiply by? Just the radical part is enough. You don't need to multiply by that other part. So a negative over a negative is a positive. We don't need that. You get 3 root 10 over 2 times 10, which is 20. Or 2 times the square root of 100, square root of 100 is 10, so it's 20. And that doesn't simplify, so there's tangents done. Now let's do our reciprocals. For sine, we have cosecant is the reciprocal of this. What's the reciprocal of -3/7? -7 over 3. And secant is the reciprocal of this. Good. -7 over 2 root 10, which is the same as -7 root 10 over 20. And cotangent, a little tip for you. For cotangent, look at the process, see how tangent is this before we rationalize the denominator. Just flip this. Don't flip. If you flip this, then you're going to have to go back and rationalize it. Just flip this and then you'll be done. So take this and flip it. So that's, you know, negative 2 root 10 over negative 3. But of course we don't need the negatives, so 2 root 10 over 3. That'll save you, definitely save you some time there. Since you showed your work before, you get to take advantage of it.